is being.
Okay, you guys, so today we're going to talk about chapter 3. I'll probably take about 2 videos to do chapter 3, so this will be the first part 1. In chapter 3, this chapter presents basic statistics, numeric calculations that are used to describe important characteristics of the set of data. So for us, there will be 2 types of statistics we will study. Descriptive statistics, which involves summarizing or describing data with charts, graphs, tables, and numerical calculations, kind of like we've been doing in chapter 2. So examples are average on a test, average on an SAT. Inferential statistics is something we'll cover towards the end of the class or the second portion of the class. It uses sample data to make inferences about populations. This is a very powerful tool. This is one of the main reasons statistics is used in our society, is you can gather data, and based on that sample data, you can then make predictions about how the population data will come back. So this is very time-saving, very efficient. It does have its flaws. So a lot of times in statistics, you'll hear someone say we're only 90% certain, or we're only 95% certain. In general, when you're using inferential statistics, it's rare you will be 100% certain. There's always a little margin of error. And that's when we'll get into hypothesis testing and confidence intervals and things like that. So measure of center. So a measure of center is a number that represents the central value of the data. For us, one of the most important ones and one of the most common ones that we use that makes a lot of sense to us is the mean. This measure of average is found by adding up all the values in the data set and dividing the number of values. So this is just like a really fancy formula that you see here. X bar is how we will represent the sample mean, and mu is how we will represent the population mean. In general, when you're using Greek letters, you're probably talking about the population. And when you're using regular letters, you are probably talking about the sample. But in each case, I think you guys know how to find the average of something. You just take all of those things and you add them up, and then you divide by the total number of items or individuals that you're dealing with in the data. And then the same thing for mu. Okay, so the average value of population size n. So one thing we have to keep in mind when we're dealing with the mean is the mean is influenced by a skew in distribution and sensitive to outliers. So it is not an appropriate measure of center in these cases. It is not resistant to outliers. So if there's outliers in your data, a lot of times you might use the median when I'm grading tests and I try to find a way to decide if I'm going to curve the exam or not. I normally look at the median instead of the mean. Sometimes people didn't really take the test seriously and get like a 5% outliers from the class, but they would drastically bring the mean down. They would lower the mean and make it look like the class did worse than it actually did. Sometimes I've even noticed the median to be about 10% higher than the mean when I'm looking at averages of my class scores. So a lot of times the mean is really good for nice, data like this. Normal distribution or something that's approximately normal. I mean, you could still try to use it, but it's and skewness can cause problems. So in those cases, when there's skewness or when it's into the median. So the mean is the most appropriate measure for of center symmetric distribution on each side of this in half. You could see that this side mean makes a lot of sense to our mind. Then the reason we like to talk about the center of data is because if we know the center, then we kind of have a in the American League in 2001.